Okay, good morning, students. Today we are going to see the pin diagram for 8085 processor. Right here we are having a single IC, that's 8085. Right, so this IC is 8085 IC. Right, that IC we are having now 40 pin IC. 20 pin left side and 20 pins are like the right side, right? So that is here we are one to here you have to start with the top left, right? Top left you have to consider as one, right? So here actually we are having now one circle will be there, right? So that is the starting point of that pin 1 to 20, and then here 21 to 40. So 40, this is 40 pin processor, right? Now here we are having now that many signals we are going to have that one as in the pin diagram, right? So here you see that the original IC here to show that. So this is the original IC, right? So where we are having now, I told you that one, this is a small circle is there, right? So that small circle is there, then that is the starting point. So this is from left, we are having now the top left of that IC, then 1 to 20, then the same way we are having that another 20 here. So 20 to 20. So the cost of that processor is 189 rupees with GST. So that is around 200 rupees. So actually the 250, then some concession that they are giving now as 189. So with the GST, so it will reach to around 220 rupees per IC. One IC is 220 rupees. The IC is 8085 IC. Okay, that IC we are going to show now as in the pin diagram. Okay, now you see the signals, right? So here first x1 x2, that x1 x2 is used for connecting the oscillator. So oscillator is crystal oscillator. So here we are having now that in physics you studied about that crystal oscillator. Then the crystal oscillator is around 6 megahertz. Then the 6 megahertz is split into half, that is 3 megahertz signal. 3 megahertz signal is pass on to that IC, right? The signal is actually 3 megahertz clock pulse. So clock pulse is here, right? So here we are having now the 3 megahertz, right? So this is one clock pulse. So around 3 into 10 power 6 pulse per second. Pulse per second it is generating, right? Now that the signal is going to be used for executing some operation within that processor, 8085 processor, right? Next we are having now that reset out. So that is we are having now reset in is here, 36th pin is reset in. So the reset in is here we are having that keyboard. In the keyboard we are having that reset key, right? So the reset key is there. So while reset key is clicking now, then it will go to the initial state. So the processor is going to initial state as the program counter is going to have that all zeros. So that is initial state all zero. Then every internal devices are going to have that initial state. And also suppose some other devices are connected, that devices also is going to be that if the processor is reset, then all other devices also going to be reset. So that one is connected with that reset pin, reset out pin. So that device, so if you are resetting that processor, the connected device also is going to be whatever the connected device is going to be reset, then that also we can use the reset out. So the reset in is going to connect with the reset out. So everything device go to the initial state. So that is reset out, right? Next one is serial out data, serial in data. So these two pins are used for if you are having that another microprocessor. So here we are having now another microprocessor, right? So the same 8085 another microprocessor where we are having serial out SOD and SID, right? This SOD is connected with SID here. Then this SID is connected with SOD. Then these two processor can interact. So the two processor can be communicated, right? So this is another IC 8085. This is another IC. So the IC to IC communication we can go through the serial communications. The serial communication means bit by bit communication, right? Bit by bit we are communicating now through that two lines. That is called serial communication. serial communication. So we are having two types of communication. One is parallel, another one is serial communication. The serial communication we are having bit by bit we are transferring. The parallel communication we are having byte by byte we are communicating. So here we are using only serial communication. Next we are having now. So this is actually we are having now that these are all the interrupt. These are all the interrupt signal: trap, reset 7.5, reset 6.5, and reset 5. So that we are having that the external interrupt can communicate with that device, can connected with that pins. Trap, then we are having RST 7.5, RST 6.5, and 5.5. Trap is having highest priority, then these are the lowest priority. Right? So that if you are having that entering into this interrupt signal, then that interrupt is going to have this one. Then here which one is the corresponding interrupt, which it is what is the interrupt we are having, right? So that interrupt, the general interrupt line is going to connect with that. So if one interrupt is occurred, then the signal is going to communicate with the processor, right? Then if the interrupt is going to be serviced by the processor, then it will send the acknowledgement. So I am servicing the internet in the interrupt. So that is here we are having now the communication, right? Next here we are having now that these are all the we are having the address line, 16-bit address line, right? So the 16-bit address line, so this is actually multiplexed, that up to the 0 to 7 is multiplexed as address and data, right? So that is we are having the buses having that around 16 pins. So 16 pin means 16 line of bus. So this is we are having the punch of that wires, so you call it as bus. So here we are having now the total 16 is going to have, that is A0 to A15. So that is we are having now 16 line, right? So you assume that one we are having 16 line, right? So that one is going to be used for address, right? So that address is here, if you are having that 8000, so this is 8000 this is 8, then followed by 40, then this is for 4 zeros, then this is for 4 zeros, and this is for 4 zeros. So the 16 lines are having now in that connection. So that is we are having now that holding now that address is 8000, right? So that is highest pin is 1, then all other pins are 0. So that is we are having now that one as 8000 in the address bus. Now this address bus and a data bus is going to have that multiplex, means this half of the bus is going to be used at the time. If you are using for address, then it will be used, then the afterwards then we can use it as a data bus. So the data bus can communicate in both directions, so in the address bus and data bus, right? So that data bus is going to be used for transferring the data. So the transferring the data through that line, right? So that is multiplexed that one. So this is address or data, right? So that is either address or otherwise we can use that data, right? Then the remaining that 15 pins of address pin is going to have that one, right? So that is here A8 to A15. So that is we are having now this this 8 pin and this 8 pin is going to combine together. We are having that 16 pin bus. The bus is address bus or data bus, address or data bus, right? Next, then the many IC we are having now that one, the left bottom is going to have as a ground. So we are connecting with this one as ground is we are having now. Then this is we are having now power supply, 5 voltage power supply for this particular processor, 5 voltage DC we are going to connect with the particular line, right? So that is we are having now that power supply, the power supply. Then here we are having the ground, right? So if you are having that power supply, so we are having now plus and minus. So the plus is going to connect with that one, the minus is going to connect with that one, right? So that is ground. So we are having now high voltage supply, right? Then here we are having now that S0 S1 IO, right? So this is S0 S1 along with that IO we are having the communication with, right? So that one as we are using now the cases is here S0 I0 I1. So this one, right? So IO or memory, then S1 S2, right? So this is we are having now the IO or memory, right? So that if you are having now that one, this is IO operation. So IO input output operation. So we are having IO devices communicate, right? So that is IO devices communicate. IO devices communicate. Then IO device we can read the data from the IO, then write the data to IO. Then we are having that interrupt acknowledgement we are going to have now as this IO, right? Then here we are having now this is a memory. 0 is memory, right? M bar, that M bar is that, here we are having that dash, that is M bar. M bar is, here we are having 0, then that signal is 0, then it is the memory read, right? So opcode pitch. So this is a program. In that program we are having that, for example, LXIH, we are having that opcode is 21, then followed by we are having that address 0090. So that is we are having now this cases where we are having this is opcode. So this opcode is read from your program memory. So that program memory, we are having memory area, we are reading now, that is memory read to instruction register. Instruction register. So that opcode is going to move to instruction register. Then where we are having instruction decoder, the decoder is going to give the signal for what operation we are going to do for that, what micro operation we are going to do for that LXIH, right? Now here we are having now that this is this S1 and S0 is 1 for opcode page. If you are having memory read, S1 is 1, S0 is 0. Then memory write, then we are having now this is 0, this is 1, right? So that memory read and memory write is, we are having that memory, then we are reading the data, already existing data, then we are reading that one, right? That is memory read. Then some data from the external world, then we are placing the data, this is write. So that memory read and write operations we can do now. Then if we are having this signal, this group of signal is showing that one, this is IO read, right? This group of signal is going to have that one as IO write, right? So the interrupt is going to be acknowledged at the time, then you should have that 3 signals, all 1, right? The all are 0 at final, that is halt. So that is we are having now the halt signal. Then memory read, so we are having the 0 1 0 is memory read, 0 0 1 is we are having now memory write, right? So like we are having now this combination of the signals for the corresponding operation. So IO fetch operation, memory read operation, memory write operation, then IO read, IO write, then interrupt acknowledgement and halt. That the one we are going to use by the signals, right? Then here we are having now address latch enable. This address latch enable signal is used if at the time of the 16 bit is going to have that address. Then here we are having the address multiplexer in the memory. This multiplexer is going to give the address latch enable, so that 8000 is going to be retained, even though the bus is going to be used for another purpose. 8000 is going to be retained, right? So the 8000 is hold on the particular multiplexer. Then this 8000 location of the memory is enabled. Then we want to read or write data. While read a data, the 21 is going to be read now. That read is going to have us the bus to instruction registers. So that is we are having now the read operation, right? Then this address latch enable is going to latch the address on the memory. Now read write, right? So for read, so if you are using the writing, so writing is from processor to memory. So the writing signal, this signal is going to be low, then we are having now the write operation. If this signal is going to be low, then this is in the read operation, right? Then here we are having that the data is going the device is going to be ready, then it is giving that ready signals, right? So ready signal, actually that is ready signal is actually we are having the DMA controller. DMA controller is used for direct memory transfer. The for direct memory transfer, we are having the DMA, right? So I think you are studying that DMA in computer architecture. So in that computer, TMA controller will be there, right? So the TMA controller will control the communication between the memory to external world. So that at the time the processor is going to be relinquished, right? So it will ask that one. So I am going to do that memory read operation. Then it will send acknowledgement. Okay, you do that memory read operation. Then I will do some other work, right? Like it will have that the handset signal will be there. Hold the holders, here we are sending now that one, right? So that is if the device is ready, then we are getting now the device ready, right? So if that clock is going to be used as clock out, then we can synchronize that external device along with the processor, right? So in which speed that processor is working, the same speed that the external device is working through the clock pulse. So that a common clock pulse is going to be connect with the external devices as well as the processor. So this crystal signal is going to be with clock out. The clock out is going to communicate with that device, right? So these are all the pin description that in 8085, right? 40 pins are having that one, right? So for each pin we are having now the corresponding purpose. Okay, we can stop here. So this is the explanation of the pin description of 8085. Okay,